Hello everyone, my name's Karen Healy and I'm Craig Country Parks Environmental Officer. Today's session is Sink, Float, Swim and Flow, which is looking at the forces that exist in water. First, we have to understand what force is. So everything on Earth is powered by forces. These are pushes and pulls which act on our bodies and the things around us. They make things either move or stop. So take gravity here, for example. This is a force of attraction that exists between two masses. It keeps us safe on our spinning planet without being flung off. An apple falling from the tree is also an example of gravity. Friction, on the other hand, makes things stick or slide. So when walking, your shoes and the ground experience friction. Centripetal force is a thing that makes things move in circles. So these are all examples of force. So we know put simply that friction is two forces working against each other. So what happens in water? Water resistance or fluid friction happens when objects float or move in water. Look at the swimmer. There are actually four forces acting on him. His weight, the upward force of the water keeping him buoyant, him moving forward with his hands and moving through the water, and then the water itself is pushing against him as he moves. So now we're going to look at density. The density of matter is how tightly packed the matter is, the amount of mass in a given space. So a solid would be more dense than a gas because there's more matter packed into that given space. Here we have a density column. You can actually make one of these at home if you get your parents' permission. It can be done with things that you already have in your cupboard. So if you look at the jar, each of these liquids have different number of molecules squashed into the same volume of liquid. So this makes them have different densities. So the more dense something is, the heavier it's going to be. So if you look at the jar, the honey and the bolt would have the highest density, which means they're the heaviest, so they sink to the bottom. The one with the lowest density is the ping pong ball, and that stays to the top. So here's the experiment in action. At the bottom you have the honey, the middle the water, and the top the vegetable oil. So we can expect the bolt to be heavier than all of these, so we expect it to sink to the bottom. Now if you put a ping pong ball on there, where's it going to go? So what happens if we mix water with oil? So here we have our water. I'm just going to add some oil and we watch what happens. Let's try and stir it and see what happens. So the oil is less dense than water. See it floating on the top? We love water at Craig Country Park, from canoeing, kayaking, raft racing, inflatables, up here jumping, even swimming. We love water, but we've often wondered what makes things sink or float. For something to sink, the downward force has to be greater than the buoyant force. This is just the force of the water pushing upwards. So if something's heavier than the buoyant force, it's going to sink. For something to float, the buoyant force, or the force of the water pushing up, is going to be greater than the force pushing down, so it floats. Right, so here's our density experiment. So here we have a jug of water, a feather, pound coin, marble, a stone, eggshell, a wee piece of plastic, and a shell. So we're expecting the heavier or more dense objects to sink and the less dense objects to float. So let's see, we'll check the coin first. What do we think is going to happen? Straight to the bottom. And an eggshell. What about a shell that you'd find on the beach? Oh, straight to the bottom. So the shell and the coin are dense. The eggshell is less dense than the water. What about the piece of plastic? Less dense. Marble. straight to the bottom. The stone, better put this in carefully. Of course, it sinks straight to the bottom. And the feather, light as a feather, floats. So here you can see now. The egg, the feather and the piece of plastic are floating. The coin, stone, shell and marble are at the bottom. So they're the dense materials, and the less dense materials are floating on the surface of the water. So you can see why it's important to put litter in the bins. So the likes of this plastic, if we drop this in the streets, it would end up in the rivers and oceans. Well, this looks like brilliant fun. Watch the girl splashing into the water. Notice how she pops up on the surface of the water almost immediately. Why do you think this happened? It's because she's wearing a buoyancy aid. A buoyancy aid is a flotation device that you wear when you're canoeing. It allows you to move around in the water with ease, so you can paddle, you can swim and move around. Now inside the buoyancy aid there's special foam. Now this foam is less dense than water, so we know when something's less dense than water, it floats. So if you jump off the pier at Craig Country Park, the buoyancy aid will bring you straight to the surface. There's all different types of life jackets. You can get ones with special plastic foam inside or with carbon dioxide inside, which is a gas. Now we know the plastic foam and the gas is lighter than water, less dense than water. So if you're wearing this, you'll float. So life jackets all serve the one purpose. They're life-saving equipment. Another thing we've often wondered when we watch people canoeing at Craig Country Park is why do canoes float? So we found out that the upward force of the water is much greater than the downward force of the canoe. In other words, the force of the water pushing up the boat allows it to float. The canoe shape as well also helps make it float. We were hoping to do this experiment to Craig Country Park, but because of the current restrictions for COVID, we couldn't. So hopefully later in the year we'll be able to upload a video for you to see. But in the meantime, you can have a look at this fantastic video from the Arizona Department of Environmental Quality. It shows you how they can estimate the speed of flowing water in a stream by using a float method. Thanks for listening. We hope you enjoyed the session. If you want more information or want to arrange a visit later in the year, visit www.craigandcountrypark.com.